Section 7.5, integer exponents. All right, well, in section 7.4, we had a list of rules of exponents. In fact, we had 6 rules. Here in 7.5, we're going to add 2 more rules. I'm going to call them rule number 7, rule number 8. And again, we'll talk about why these rules make sense, why these rules are what they should be. The first rule is if I take something to the 0 power. Okay, so this is what we mean by integer exponents. In section 7.4, we only used counting numbers, 1, 2, 3, 4, 5. Now we're going to talk about having a number raised to a 0 power and having things raised to negative powers. All right, so b to the 0. I think you would agree with me that 1 is the same as 3 squared over 3 squared. 3 squared over 3 squared, that's 9 over 9. 9 over 9 is 1. You divide any number by itself, you get 1. At the same time, if I use my rule for exponents, rule number, what rule was that? Rule number 3. Rule number 3 tells me I can subtract my powers. So I would get 3 to the 0. So the number 1 is the same as 3 to the 0. And I think you would agree with me that there's really nothing special about the number 3 there. I could do the same thing with any number, except for one of them. We'll talk about that in a minute. 1, for example, is 8 to the 12 over 8 to the 12. Well, I don't really know what 8 to the 12 is. 8 to the 12 is a really big number, but I know if I take something and divide it by itself, I get the answer 1. At the same time, I can subtract my powers. 12 minus 12 is 0. So that's the same as 8 to the 0. So b to the 0 is the number 1, but again, we have to have the little rule. B can't be the number 0 there, because I can't do that trick. I can't take 0 squared divided by 0 squared. I can't have 0 on bottom. Okay, so 0 to the 0 is said to be undefined. We don't discuss 0 to the 0. All right, rule number 8, our last rule. Actually, I'm going to add in a rule number 9 that's not in the book, but I think it's a good one. Rule number 8 says, what do you do if you have a negative exponent? Well, let's see. How about 4 to the 3rd over 4 to the 5th? According to our properties of exponents, rule number 3, I can subtract those powers. 3 minus 5 gives me a negative 2. So that's 4 to the negative 2. On the other hand, 4 cubed over 4 to the 5th is, I got 3 4s here. I got 5 4s down here. I can reduce. And I'm left with 4 2s down on the bottom. All right, so 4 to the negative 2 has to be the same as 1 over 4 squared. All right, and that's rule number 8. Rule number 8 says, if I have a negative power, it moves the negative power to the bottom. If the negative power is on top, the negative power is moved to the bottom. And again, this rule is good as long as b is not 0. Can't have 0 on bottom. Rule number 9 is a good one. It's just kind of the converse. If I have a negative power, but the negative power is already on bottom, then the negative power rule moves to the top. Right, so rule number 8 and rule number 9 I kind of think of as one rule. Negative exponents simply interchange top and bottom. If I have a negative exponent on top, it goes to the bottom. If I have a negative exponent on bottom, it goes to the top. All right, so again, let's do a bunch of examples in this section, and we'll see where we are. X to the negative 2. We have a negative exponent. It's on top. It moves to the bottom. There's a simple one. 1 over b to the negative 5. Here I have a negative exponent, but it's already on the bottom. If I have a negative exponent on the bottom, it comes up to the top. Oops, that would be b to the 5. So again, negative exponents, all negative exponents do, interchange top and bottom. b to the negative 3 over c to the 5th. Well, this time I notice I have the b. The b has a negative power, so the b is going to move. However, the power on the c is positive, so the c is going to stay right where it is. So this becomes 1 over, the b moves, b cubed, the c doesn't, c to the 5th. C had a positive power, stays where it is. 3x to the negative 1. All right, this one I see a lot of students miss. And what I will see a lot of students do, this is wrong, so I'm going to put not equal to, they will write 1 over 3x. All right, and what's wrong with that? Well, what's wrong with that is the order of operations. 3x to the negative 1, remember there's really a multiply in between right there. We don't write it, but there is. And what comes first, powers or multiply? Powers come first in the order of operations. So the only thing that moves here is the x. The only thing that has the power on it is the x. The number 3 does not have the power on it. The number 3 does not move. So that one should be 3 over x. If I wanted the 3 to move, I would have to write this. I would have to have the 3 with a negative 1 power. Now the negative 1 power is on the 3 and on the x. So now they would both move. So notice the difference on that. And that's this right here, like I say, this is a very, very common mistake. Try to avoid that. You got to recognize the power there is only on the x. It's not on the number 3. All right, let's look at a few more of these. How about b to the 5th to the negative 8. All right, well, this goes back to section 7.4 a little bit. We've got a power followed by another power. I multiply my powers. That's going to be b to the negative 40. 5 times negative 8 is negative 40. And then the directions generally are write your answer without having negative exponents. So without negative exponents, I have to drop that b to the bottom. So that's 1 over b to the 40. All right, how about negative 5b to the negative 3 times negative 8b to the negative 5. All right, again, I start with my coefficients, start with my numbers out front. Negative 5 times negative 8 is positive 40. And then I do my powers. I add them. Negative 3 plus negative 5 is negative 8. So I have 40 b to the negative 8. And once again, this is like this one up above that I circled. Only the b moves. B is the only thing that has the power on it. The number 40 does not have a power. So that should be 40 over b to the 8. All right, a couple more problems here and we'll be all done. How about 4b to the negative 2 divided by 9b to the negative 5. This is such a good problem that I'm going to do it twice. I'm going to show you 2 different options, 2 different ways you can answer this one. Here's way number 1. Method number 1 is, I see that my b's have negative powers. I have a negative 2 on top, that would move down to the bottom, and I have a negative 5 on bottom, that would move to the top. Again, the 4 and the 9 don't move. The 4 and the 9 do not have powers on them, so I could write this as 4b to the 5th over 9b squared. I simply move the negative powers. Now, I go back to my rule in section 7.4, which tells me to subtract my powers. So that would be 4b cubed over 9. All right, here's the alternative way to do this one. 4b to the negative 2 over 9b to the negative 5. My subtraction rule still works. I can take and subtract my powers. I could go negative 2 minus negative 5. Minus 2 minus negative 5 is minus 2 plus 5. That's 3. So this becomes 4b cubed over 9, and I've done in one step. Which way is better? I find most students tend to like the first way better. They like to get rid of the negatives right away and just move things top and bottom. Personally, I like the second way better because it's a little bit quicker, but that's my choice. All right, how about, see, I'm looking in the book for some good ones here. How about 2 to the 5th, b to the negative 7, divided by 2 squared, b to the negative 2. All right, well, I'm just going to go ahead here and I'm just going to subtract my powers. I'm going to do it the method I prefer. So my 2's do have powers, so I would subtract my powers, that's 2 cubed. And then I would look at my b's, and I got to take negative 7 minus negative 2. That's minus 7 plus 2, that's minus 5. So I'd have b to the minus 5. 2 cubed is 8, and the b goes down to the bottom because it has a negative power. All right, one last problem. Let's pick one of these real complicated ones here and see what we can do. How about 5b to the 4th, c to the negative 2, divided by 7b squared, c to the 4th, and then the whole thing is raised to the negative 2 power. All right, well, I would begin inside my parentheses. That's what the order of operations tells me to do. Parentheses first. So let's see, my numbers out front, I got a 5 and a 7. I can't reduce a 5 and a 7, so I'll just write those down again. Looking at my b's, I subtract my powers. 4 minus 2 is 2, so I get b squared. My c's, I subtract my power. Negative 2 minus 4 is going to be negative 6. That's c to the negative 6. All raised to the negative 2. Okay, I think I'll do one more thing inside my parentheses. I think I'll write that as 5b squared over 7c to the 6. I'll take that negative power and move it to the bottom. All right, now I'm ready to distribute this negative 2 through. So I'm going to have 5 to the negative 2, b to the negative 4. I multiply my powers there because I got a power followed by another power, divided by 7 to the negative 2, and c to the negative 12. All right, almost done. Everything's got a negative exponent on it, so everything's going to move. So this becomes 7 squared c to the 12. The two things on bottom come to top, and the two things on top go to the bottom. 5 squared b to the 4th. Last step, I think I would write 7 squared as 49. 49 c to the 12 divided by 25 b to the 4th. So that's about as complicated as they're going to get. Take them one step at a time. Go through, use your rules. You should be okay.